these events. So good afternoon, everyone. Welcome to the Need for Speed talk at London's Calling. This is going to be a whirlwind dive through every little thing you might need to think about to help improve performance. This is all basically around the idea that when someone clicks a button in your app, they're going to have to sit and wait for stuff to happen. And like, how many of you here have been using an app and clicked a button and it not done anything, and then you've sort of sat there and waited patiently for 10 minutes and not got upset? How many of you then sit there and go, click, 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 click? Yeah, everyone. So, yeah, whenever a user's using your app, you want to make it quick, you want to make it fast, and so these are some tips to help you how to do it. Before we dive in, I want to start off by talking about how we're going to make things faster. So, how do we go about doing performance improvement? How do we go about making sure that we do this in a controlled manner rather than just, wasting time for no reason? So Amdahls Law, if you've not heard of it, basically says that whatever the improvement you're making needs to be worthwhile. So if I spend 200 hours making something go 0.01 seconds faster, and it's not a well-used feature, I've just wasted time. Okay, you need to make sure that whatever the return is, the investment was worthwhile. So the methodology I like to follow is called OODA, and it's a methodology that was from the US military. Okay, because they're the right guys to do in every case. And it starts off with observation. So what you do is you observe what's going on. You have a look at your system, take some measurements. Is this page being slow? Why is it being slow? Which areas are being slow? Make sure you know what's actually occurring. We then orient. So we take our data, we look at it, and we analyze it. So there's a great Heroku blog post about the 95th percentile. So if 95% of your interactions are within a certain range, you don't need to do anything, as long as that range is happy. Like, you need to look at the statistics, look at the analytics you've got, and make sure it's something that's worthwhile bothering to go with. That one case in 1,000 where someone sat there on a 1G network trying to run a batch Apex job, probably don't want to bother wasting a lot of time with it. You're then going to make a decision. This is the part where you need to get all your business stakeholders involved. This is the part where you need to decide if it's actually monetarily worth it, because going away and spending hours coding or doing whatever just to improve performance means that you're not doing another feature. And who here has a client or a business owner that prefers things to be ever so slightly quicker rather than a nice new shiny feature? Like, everyone likes new and shiny stuff, right? So you've got to make sure it's worthwhile. If it's something that's really causing people problems, you have to make sure they understand, okay, we can do that, and it's going to result in this sort of performance improvement. These are the metrics we're going for. This is how much we're going to try and improve it by, but this is what it's going to cost you. And there's also no guarantee for a lot of these things. You can't guarantee you're going to be able to make it faster. And then finally, you act. You go away, you look in your code, you see where your bugs are, you try and improve it, try and make it faster, and make the right decisions based upon it. So when I was coming up with this talk, this is version 2 of this talk, okay? Version 1 was just sitting down and I'd open up a big screen of code and I'd go through it and I'd show you all of these different ways you can make things faster. And after about an hour, we'd be finished. And apparently, I've only got 25 minutes. So doing an hour-long presentation isn't a good idea. Simon will get mad at me and he will kick me out. So what we're going to do today is we're going to talk through the interaction lifecycle that a user has. And we're going to talk about the different performance improvements you can make at each stage, some of the things you need to think about. And I invite you to go away in your own time and look at some of these areas and think, oh, I haven't thought about that before, okay? Obviously, everyone knows premature performance improvement is the root of all evil. Make sure you're doing things for the right reasons, but these are some of the areas. So first area we're going to look at is when a user loads a page. This could be Lightning, this could be Visualforce, this could be a Heroku page. Doesn't matter, we're going to think about that first page load. That's what everyone notices. That's what takes time. Hands up who got really annoyed with that snowman winking at them. Right? Step number 1, user loads a page. Step number 2, the user then interacts with that page. It might be entering data. It might be clicking on a report. It might be drilling down into something. It might be switching tabs. It might be any number of things that are going to cause some interaction with the server or interaction with the page to make a change. Typically, we then save something. Most people go into Salesforce to add, update, or delete records. Very few people go in to do nothing. If you have people with licenses that are going in to do nothing, you might want to look at whether or not they want licenses. But this is where really everything takes time. This is that stuff that when you click the save button and it goes away and it does your workflow, your flow, your process builder, your triggers, your Apex callouts, all of this stuff, your queries. This is when you're sat there as a user waiting for something to come back. And we'll talk about the governor limits and why the governor limits are there, why they're good, and why they don't tell you enough information in some places. And then finally, we're going to talk about background processes in code. So batch Apex, asynchronous calls, all of these things, and how you can improve. So lots to cover today. So first thing, user loads up a page. We'll talk about Visualforce first. Visualforce being still the predominant way that most people are using Salesforce. So first question we need to ask ourselves when we are writing Visualforce is, why the hell are we writing Visualforce? Are we using a standard page? Can we use a standard page? Can we just have an inline Visualforce page on that? Like, I've seen so many pages rewritten for 3 fields. That's just a waste of it's a waste of your time, because you're just redoing something that then the next time the admin wants to change it, you've got to go away and rewrite the page. Like, that's a waste of everyone's time. So can we just use an embedded page, or can we just do this with a formula field? Can we do it some way that doesn't involve us writing Visualforce? First of all, try not to write code. You know, Bill Gates once said that if you found him the laziest developer in the world, he would hire him because he'll know how to get things done quickest. Step number 2, are we using a standard controller or a standard controller or standard set controller? Okay, standard controllers are pre-tuned. Every other bit of code on Salesforce effectively gets loaded in and interpreted at runtime. There's a lot of caching and a lot of compilation that's done in the background, but the long and short of it is that it's not native Java code like these things effectively are. Salesforce won't be redoing their standard controllers every time. That stuff's been written to be fast, so if you can use it, you should do so. It's just going to make things easier for you, and there's utility methods. Save, delete, cancel, they're all available for you to use. Are we using static resources? Hands up here who wouldn't put any of their JavaScript or CSS or whatever in static resources. Right answer, well done people. We should use static resources. Static resources are loaded on a content delivery network. Salesforce have their own CDN that they use for static resources, which makes them super fast to load. So they load a lot quicker than the rest of your content. A really good idea to do it, and it means you can bundle things up, typically in a zip file. But we also need to think about bundling and minification. When you've got JavaScript, if you've got 12 JavaScript files spread across things, try and bundle them up. Try and minify them. So minification usually means removing it so that it doesn't look readable for a human. It can also mean that it's slightly obscured, so that it's harder for anyone to go in and read your code if you're that worried about it. But it can have a massive impact. I was working on a React application on Heroku recently, where I took 1.4 megabytes worth of JavaScript and just stuff that was going on there and minified it down to like 400K. That's a third of the space. Loads much quicker, much more easy to use. Saying this, however, though, we want to be thinking about whether we do need to use static resources, because there's always a caveat. Remember, every rule has an exception and should be broken. When working with JavaScript, if you put it in a static resource, you can then reference it using an Apex include script tag, right? Everyone's aware of that? Apex include script automatically loads your code at the top of the page. So if you've got a big bunch of JavaScript that you're not using, you've got to wait for that to be loaded before the rest of your page can be. Now, in most other web development kind of areas, you'll be told to put things at the bottom, script should be at the bottom. Put them last on the page because the HTML page loads, it reads things through bit by bit. That will stop everything else on the page from not being rendered, from being blocked. So if you've got a non-blocking piece of code, try and use it in a script tag if it's large enough to. This is an example that shows up actually a lot better than I was expecting. But I had a small test.js file, right? 359 bytes. And as you can see here, the difference in the load time was about a second. That's just from me loading it as a script tag instead. It was a small piece of non-blocking code, loaded as a script tag much, much quicker. So be aware of this massive performance improvement you can get and just stop your pages being blocked. So on to Lightning. Lightning. First thing you should ask when you are doing a Lightning component and writing code is, what data do I need to load? When do I need that data? Can I not get that data now, please? Okay? When you're using component frameworks, a lot of these things aren't going to have data they're going to need until the last moment. Okay? So if you've got, so pagination is a great example. Lightning components are typically, what, a third of the page? Yeah? Maybe a quarter if it's a big Lightning component. Therefore, do you really need to retrieve 300 records? Could you get 10 and paginate? Could you get 10 and even have it so that you fire a Lightning event when you scroll and load a few more? What do you need to get at the time to make your page run a bit faster, to make you have less data in transit, and to make things a bit more performant? Again, base Lightning components. One of the sessions I was in earlier was saying about how they were rewriting some of the base Lightning components, changing all the namespaces for these things. The base Lightning components are very similar to the standard controllers, and there are standard Lightning controllers coming in the data service. Be aware of them, try and use them again. Like, A, don't write extra code if you don't need to, because you've got to maintain it. But B, Salesforce sort of spent time tuning this stuff, okay? Always think about what you can use the client for. Now, the nicest thing about Lightning is that it runs on the client side. So if you have got data you need to manipulate, you need to get into a certain format, do you know what, you might actually be quicker just pulling it down from Salesforce and doing that manipulation on the fly in JavaScript. My laptop is going to be much quicker than the Apex execution script I've got probably. Now, if you're on a mobile device, might not be so. So think about your use cases, think about what you're doing with that data, how you need to manipulate it, how you need to change it. But definitely a consideration is to use the client more, because it will be a bit snappier and it will interact with the user a bit better. They can feel that interaction and it'll be a lot quicker. People don't want to sit around and wait. You want to try and use component level events rather than application events. The reason being is that component level events excuse me, are limited in scope, so they won't bubble up everywhere. For an application event, anything can listen out for that event. So that means everything has to listen out for that event. So when it gets fired, all of these other components will sit there and have to check whether or not they want that event or not. Minimize the amount of bubbling. If you've ever done other JavaScript on-click events and worried about things propagating up, same idea, okay? Think about OODA and keep updated on the release notes. JavaScript is really new. I mean, every time, not JavaScript is really new. JavaScript is always new as well, actually. But Lightning is still quite new, okay? There's a lot of changes going on. Things are being renamed. They're adding stuff in like the data service. Locker service is changing as well. Keep updated on the release notes and go in yourself and test it. The biggest piece of advice I can give to you for Lightning is just keep on testing and retesting. And if you are interested in performance and trying to help others, this is a great area that there's not a lot of work done in at the moment. You can search Visualforce performance, and I know I've given 3 webinars for Salesforce, I think, on Visualforce performance. I don't think I've seen a single one on Lightning component performance yet. So it's still an open area, still lots of interesting research that can be done there. And finally, remember, it's JavaScript. So everything, there's a light there, everything you've learned about JavaScript performance applies, okay? Everything you know about how to make JavaScript run faster, how to make JavaScript play nice, applies to Lightning. So the users loaded the page, they're now interacting with the page. First thing we need to ask when they're interacting with the page is, what are we re-rendering and why? When we have some interaction, it normally means you want to update something on the page. We don't have users click pages just for no reason. When we do that, we want to re-render part of that page, we want to update something on there, we need to think about how much of that we're updating and why we're doing so. If we're updating all of the page, then we have to redraw all of the page. Okay? If we redraw all of the page, that's going to take much longer than if we just update one field. This is why Lightning, why React, why Angular all use a virtual DOM. They all use a virtual DOM so they can decide what small areas of the page they want to re-render to make things much snappier. So whenever you're working with Visualforce in particular, think about, what am I re-rendering? Why am I re-rendering everything there? If you are re-rendering, have you minimized your view state? So think transient variables. Who here knows about the view state debugger? That's shocking. Okay. Everyone, when you're writing your next Visualforce page, go in to setup, turn on the view state analyzer and view state debugger. You get a little bar show up at the bottom of your screen. You can click on it, it'll show you what your view state is. You can then drill into it, see how much space is being taken up by things that you can then decide you don't need to have on the page. It'll make things a lot quicker, okay? Similarly, with Lightning, think about event propagation again. Why are we firing all these events? Do we need to? Could we use a remote action? Could we use Ajax? Could we use some other method, action function? Could we do something asynchronous, okay? Now, typically when people think of asynchronous, they think that means it goes away for 10 minutes and it works and I have to wait for it to come back. But really what we mean here is that the user's clicking the button and the page isn't refreshing instantly. It's going away, making a call out, doing some action. We're going to give the user some feedback about that action. It's happening, it's occurring. But then we can make that update. And we are sending a much smaller amount of data over the wire. You know, anyone who's read, there's a really good book, High-Speed Browser Performance, I think, or High-Speed Browser Networking Performance. Really detailed and nerdy book. There's a free version online. But first thing it says in there, minimize the amount of data you've got going over the wire. That's the easiest thing for you to control to improve any of this. And finally, how is our user being kept informed? When we were talking earlier on about smashing the mouse button 100 million times because something's not loading, I was playing a game the other day at home and it froze. Well, it didn't actually freeze. I thought it froze. It did freeze after I clicked the same button 20 times. And then I'd hit Control-Alt-Delete and I'd restarted it and I went away in an angry, angry fit. But I was losing, so that was fine. Like, I wasn't being updated that it was doing some loading in the background, right? And so I assumed it wasn't working. I assumed it hadn't clicked. I assumed my mouse had lost connection. Something like that could have happened. So make sure your user's kept informed. A little loading wheel is the best thing you can give them, just so that they know it's happening in the background. It also adds a bit of cognitive dissonance. So, that instant when the loading wheel loads, it rotates a little bit and disappears. Those 3 little time slots actually take up all of the time that this is going away and working in the background. But to a user, because they see 3 things happening, it appears, it rotates, it disappears, it seems like everything's running a bit quicker. There's a lot of psychology in this as well. And things are going to become faster and faster. So, we've done all of that. We're now getting to the point where you are sat and waiting. How are we doing for time? We're okay. So you've clicked the save button or whatever it is. You're going away and doing a bunch of stuff on the server. Everything that happens from now on, your user is waiting. Okay? So hands up who knows the CPU time governor limit. Okay, what is it? So, yep, 10,000 milliseconds, 10 seconds, okay? So you could run 10 seconds worth of Apex code and no one would complain. Salesforce would be quite happy to let you do that. Who wants to sit there and wait 10 seconds for their web page to reload or update? Okay? Now, next question. Does that include SOQL queries or not? Nope, doesn't include SOQL queries. And you can do a lot of SOQL queries. Each SOQL query can take up to, I think it's 150 milliseconds. So if you were to do your full allocation of SOQL queries, your full allocation of CPU time, you could have people just sat around waiting for 10, 15, 20 seconds. Like, at that point, someone switched over to Facebook. I can guarantee you it'll be Alt-Tab, I'm going to read BBC News, check Facebook, look on Twitter, I'm going to make a cup of coffee. Like, you've just lost that person. They're not working anymore. And that's if it's someone internal. Imagine what it's like if it's on a consumer app. If it's on a community, on something that's exposed to regular consumers and not your own internal users who are a bit more chained to the desk. You've got to be really aware of these things. So first thing is, what tool are we using and why? Try not to use Flow if you need things to be super fast or you're doing something super complicated. Flow is a really good tool, but it's a bit greedy. If you were to write a Flow and write the same Apex code to do the same thing, the code will run faster, always. Now, if you're an admin in an org by yourself, use Flow. It's a fantastic tool. It will help you for 90% of what you need to do. If you're going to introduce code, add in rewriting that Flow into code. Flow uses up your governor limits. A lot of people don't realize this, but if you make a query in Flow, it counts as a query in your transaction governor limits. I had a recent experience where I was working on a project. One of my colleagues went in, rewrote a few things in Flow, and suddenly everything broke. And it was because it was using up queries that I wasn't aware he was going to be using up. So we then had to go away and do a bit of refactoring. So try and use flow or code if you can, because it will just make things far easier for you to maintain going forward if you have one or the other. Having that intersection means that you're adding in a possible instability and a possible set of unknown outcomes. Okay. Triggers. So we're going to go through all of these 4 points real quick. But bulkification from inception is the key thing. If your first line in a trigger, or the trigger handler class, for those, everyone's probably aware of the trigger handler patterns, if your first line isn't for, then your trigger's broken. Pretty much, like if it's not a query, or it's not a for loop, your trigger's broken. You need to be able to handle bulk from the start. Even if your end user says to you, but they're only ever going to load one. Like they're just going to click and create one account. You go, that's great, but I'm going to deal with when they do 200. But they'll never do 200. I swear to you. Okay, I'm going to work with 200. Oh, by the way, we're going to data load it. There's your 200. Okay, always be prepared for it because you know it's going to happen. So let's talk about loops. Loops are one of the biggest eaters of time on Salesforce. So this picture shows up terribly, but when you get the slide, you can see this. Effectively, these are the 3 different ways of writing loops. You have the for, and then having the inline query. That's the blue bar. That takes forever because it's using a query more. Okay, it's loading things in memory as it needs to. You have doing a for loop, and then so you have doing a query, storing it in a list, and then doing for with a colon through that list. It's the gray bar. It's a bit faster. If you query using an index, so for I equals 0, j equals the length of the list, and then retrieve every item off that array using that counter, you'll just massively improve your performance, okay? Should you do this all the time? No, don't go away and rewrite all of your loops like this. But if you know you've got one that's going to take a lot of work and be processing a large number of records, this is a really good idea. I built a machine learning system on Salesforce for Dreamforce a couple of years ago, where we processed hundreds of thousands and up to millions of records, and we could make it do machine learning fairly quickly because we were using these loops. It's just a dramatic reduction. All right, powering on, query tips. You need to think about the balance between the number of queries you're doing versus the speed of them. Queries are super performant on Salesforce, okay? They always run, as I say, in, I think it's under 150 milliseconds I've seen on a marketing slide. So it can sometimes be quicker to query all the data you're going to need and then process it in one of those super fast loops versus doing multiple queries and then having to do a little bit of processing and matching up anyway. Something that's really worthwhile you testing and looking at if you're finding things are being slow or if you're wanting to just enhance the performance and make things a bit easier to work with. Queries are a really big area. Is your data structure helping you? Are you going across multiple records, multiple objects? Are you not helping yourself, really? So if you can have things on single number of objects, are you overly normalized? Think about that. Use indexes, improve your selectivity. That's really important. There's a really good set of resources on query performance, making sure you select the minimal amount, because otherwise Salesforce has got to do a bunch of work going through its massive Oracle databases to retrieve that data for you. Analyze your queries in the developer console. You can run a query in the developer console, analyze it, see what's taking time, get it improved. Other big thing you should also think about is, do we even need to do multiple queries? Same with the loops. Do we need to do multiple loops, or can we just use a query? I've seen loads of people write loops to do a count of something or an average of something. There are SOQL functions to do that. So be aware of all of your toolkit. Onto recursion real quick. So the key with recursion is knowing when to stop. Make sure that you draw out what you're doing with your overall program flow, okay? You could be doing additional work that you don't need to do. You could get unexpected outcomes. As I mentioned earlier about that overlap between flow and triggers, be really careful with this because that can slow you down. If you're doing a bunch of work that's not needed, guess what? You're doing extra work. It's going to make things slower, and it really can mess you up in the future. In terms of background processes, know your options. There's future methods. They're really good if you've just got some primitives, if you're working with two different types of objects. So if you've got setup objects as they're known, so user group, things like that. And if you've got Your custom objects, you can't deal with them in the same context, you can't make those updates in the same context. Split them out and use a future method to some of them. Cubables, far newer, but really good if you've got non-primitive types you want to work with, or if you want to chain different ones together. And batchable is when you've got masses of data. So you can have up to 50 million records. It can batch them up for you. Excuse me. You can schedule them, which is really good as well. Again, think about, do you need to do stuff now? You know, every customer will tell you, and every business owner will tell you, it needs to be done now. Does it really? Like, is anyone going to check it? Does it need to happen? Go away and figure out if it can be done on a weekly schedule, on a nightly schedule, even on a 15-minute schedule. It can just make things a bit easier for you and make it much, much better for your customers overall as well. So to wrap up with some final tips, number one, have a plan. Don't go into this and just say, I'm going to improve performance. Make sure that you're planning which area you want to work with. Measure twice, cut once. Measure again, make sure that your data is accurate. Make sure you account for things like network latency, bad connectivity, firewalls, proxy servers, all of these things. Experiment all you can, because that's a really good way of learning about these things. It's also a good way of finding out odd holes you don't know about. And finally, use all the available tools. Dev console, view state editor, Lightning console, all of these things are really good for you to use. And there's a Chrome plugin for Lightning as well that helps you inspect these things. And Simon has told me we are over and done with. So that is it. If you have any questions, I'll be around now or afterwards this afternoon. Thank you very much for coming. I hope you found that interesting and useful. And sorry it was so quick and rushed. Oh, is it clipped on? Sorry, I didn't realize.